This is about the polarization by reflection, polarization of reflection. So the ray of unpolarized light in air is incident on a glass surface at, this is called a Brewster angle theta b. The electric field along that ray have been resolved into components perpendicular to the page. The plane of incidence, refraction, and component parallel to the page. So suppose the incident wave is unpolarized. So you can see this orange dot represent the polarization is into out of the page, and the green arrow indicates that it is parallel to the page. This is perpendicular to the page. This is parallel to the page. So suppose the input angle, the angle of the incident wave has a Brewster angle. In this case, the refracted wave is polarized, although the refracted wave is still unpolarized, but at least the refracted wave is polarized. So only the component perpendicular to the page refracted. So this angle is like n2 over n1, and take the arctangent. And this should, so the reflected light consists only of the component perpendicular to the page and is thus polarized in that direction. The reflected light consists of the original component parallel to the page and weaker component perpendicular to the page. The light is partially polarized. So we call it partially polarized because for this one, it is unpolarized, means both component, the component perpendicular and parallel is roughly the same. So for this one, only the perpendicular component reflected. So which means that the perpendicular component for the refracted wave is weaker than the component parallel to the page. So as shown in the above refracted wave, which will be fully polarized with its E vector perpendicular to the plane of incidence. If it strikes a boundary at the Brewster angle, where this one. So it's also satisfy this angle to be 90 degrees. This angle to be 90 degrees. Why is it like this? Maybe. Let me see if I can derive it out. So we have sine theta 1 over sine theta 2 is n2 over n1. N2 over n1. Right. Yeah, n2 over n1. So so now theta b is actually theta 1. So now we have theta 1 equals to theta b, which is arctangent n2 over n1. So we take the sign to this one, which means that this angle is something like n2 n1. This is theta b. So this is theta b. So we have a sine theta 2 equals to sine theta 2 equals to n1 over n2. N1 over n2 sine theta 1, which is this one, this is nothing but sine theta b. So sine theta b, this one should be n1 square plus n2 square. Take the square root. Oh, like this. So sine theta b should be n1 n2 times this one should be n2 over n1 square plus n2 square. And this one can be cancelled. So this one should be n1 over square root n1 square plus n2 square. So this one should be nothing but this one over this one. This one over this one. Which means that this one should be maybe like cosine theta b. Cosine theta b. So this one and this one, we have sine theta 2 equals to cosine theta b. So in this case, this one should be a sine pi over 2 minus theta b, which means that theta 2 equals pi over 2 minus theta b. And it turns out to be, this is theta r. Theta r is actually theta 2. So we have theta r plus theta b to be 90 degrees, pi over 2. So this is the Brewster angle. This is the Brewster angle. Any questions? Okay. So we have additional example. So first one, so unpolarized light is sent into a system, unpolarized light from here. So unpolarized light is sent into a system of 3 polarizing sheets. The angle theta 1, theta 2, theta 3 of the polarizing direction are measured counterclockwise from the positive direction of the y-axis. And they are not drawn to scale. Angles theta 1, theta 3 are fixed, but angle theta 2 can be varied. So these two is already fixed. These two are already fixed. This one can be varied. This one can be varied. So the intensity of the light emerging from sheet 3 as a function of theta 2. The scale of the intensity axis is not indicated. What percentage of the light initially intensity is transmitted by the system when theta 2 is 30 degree. So actually we need to observe this figure. So in the x-axis, we can vary it from 0 to 180 degrees. Actually, it's not reasonable to further make it to 360. Actually, this axis, 0 degree and 180 is actually the same. So there's no point to further extend this x-axis. So this is intensity. We can observe that if theta 2 is 0 degree, 90 degree, 180 degree, the intensity is 0. The intensity is 0, which means that sheet 2 is perpendicular to either of the sheet when theta is this triangle. Otherwise, there's no point that the intensity should be 0, because we have the factor cosine square theta, cosine theta square. So it should be perpendicular to either of them, which means that we may consider theta 1 to be 0 degree and theta 3 to be 90 degree, or vice versa, but it doesn't really matter. As long as we need to multiply them one after another. So the order is not really important. So what percentage? So the point here is that I equal to 0 at theta 2 equals to 0 degree, 90 degree, and 180 degree, which means sheet 2 is perpendicular to either of them. At 0 degree, 90 degree, 180 degree. So which means when theta 2 is 90, maybe one of it is, well, suppose this is theta 2 is 0 degree. So either theta 1 or theta 3 is 90 degree. So we may only pick one of theta 1. So we may pick theta 1 to be 90 degree. Theta 1 to be 90 degree. And when theta 2 is 90 degree, it's also 0. So theta 1 cannot be 0 or 180 because it is fixed. So we can only pick theta 3 to be 0 degree. Theta 3 to be 0 degree. Or maybe you can pick theta 1 to be 0 degree, theta 3 to be 90 degree. The answers will be the same. So without loss of generality, we may either pick one of them. Okay. So actually, maybe we call it I3. I3 should be equal to, so suppose at the very beginning it is unpolarized. So after the first one, it should be 1/2 I, 1/2 I0, maybe I0. And then suppose it asks you about what is the light intensity, percentage of the initial light intensity. Maybe I can just derive this term to be to the left hand side. Can just derive to the left hand side. So it is somehow like maybe I3 over I0. So we have the 1/2 factor for the first one. And then for 30 degree, so we have 90 degree minus 30 degree, which is 60 degree, cosine 60 degree square. And then from theta 2 to theta 3, so we have a 0 degree minus 30 degree. So we have another cosine square 30 degree. So it turns out that to be 9.4%. Actually, the same answer with the previous example. So any question regarding to this one? So the next one, a certain helium neon laser emit the red light， 就是那个氦氖镭射，emit red light in a narrow band of a wavelength center at 632.8 nanometer， 就是那种镭射笔那种，就那个波长是632.8纳米，with a wavelength width of 0.0100 nanometer. What is the corresponding frequency width for the emission? "那你们学完那个 Fourier transform 了吗？学完 ，OK。那你们知道就是说 so you should know that suppose you have a cosine maybe omega t. So if you take the Fourier transform, it should be something like let me see, it should be something like pi minus maybe omega 0 plus a pi delta omega plus omega 0, something like this, right? Something like this. So this should be a delta function. It should be a delta function. So actually, if you draw it in omega axis, so maybe this is something like x j omega, something like this. So this is a delta function. This is a delta function. This is a delta function. This is omega 0. This is minus omega 0. 如果我记错那个给错一个Fourier transform 不是減，cosine 我 cosine 係減，cosine 應該加。揾下先，我抄錯咗。cosine 應該係加嘅，即係呢個。So this one should be something like 1/2 exponential to j theta plus 1/2 exponential to minus j omega 0 t omega 0 t something like this. 抄錯，我幫你改返。This should be a delta function, but actually in the practical world, it wouldn't appear like this. It wouldn't appear like this. This is delta function, delta omega minus omega 0. This is delta, maybe a pi omega plus omega 0. But actually, in the real world, it's something like this. it should have a width. It should have a width. So we call it maybe there is something like uh, maybe this is the omega zero, omega zero, and there should be something like the delta omega, delta omega. So there should be something like a peak here, peak here. So we may consider half of the height and then consider the width. So we'll consider is the width of the frequency. So if you consider is the wavelength, so we have another equation like this: C equals F lambda. F is the frequency. F is the frequency. This is the wavelength. And of course, omega is 2 pi f. So maybe you can just C equals 2 pi f times lambda over 2 pi. So this should be omega lambda over 2 pi. Or maybe you can express this term as 1 over k, and what you like. So in that case, if you draw it in lambda domain, if you draw it in lambda domain, if you draw it in lambda domain, it should be something like this is maybe lambda zero, lambda zero, lambda zero, f0. So lambda zero, there should be something like this, and this is actually this is the wavelength. In this question, it is 632.8 nanometer. 632.8 nanometer. And this is actually 0.0100 nanometer, like this. So it's just you about what is the corresponding frequency width. What is the corresponding frequency width here? Or maybe delta F, delta F. Okay, so just mention we have F equals C over lambda. Or here we have C equals F lambda. So actually, we know that C is a constant and F is a variable. Also, lambda is a variable related to F. So we may take derivative on both sides. Take derivative on both sides. So we have a df equals dc over lambda, which is c is a constant, so it is something like c times d 1 over lambda, 1 over lambda. So in that case, we have c. This is lambda to the -1 order. So it should be something like -1 over lambda squared. And then d lambda. So this is a chain rule. So it's something like this. Or we may write it as minus c over lambda squared d lambda. Okay. So actually, delta F. Delta F is what we want to find here. So so actually we just take you just ignore the minus sign, because for this case, if F is larger, this goes to the smaller side. This is lower frequency, go to the higher side, but we don't really care. We only care about the width of that beam. So C over lambda square d lambda. And C is nothing but 3 times 10 to 8. 3 times 10 to 8. And then over so this is 632.8. Oh. 632.8 times 10 to minus 9 square. And then times delta lambda is 0.0100 times 10 to minus 9. Something like this. So in this case, this is 7.49 gigahertz. It looks like very, very, very large, but actually relative to the frequency of the light, this is quite low. We can simply check it here. So suppose we have a C over lambda. So F equals C over lambda, which is something like 3 times 10 to 8. And then this one is 632.8 times 10 to minus 9. So you can see that 8 plus 9, 17. Maybe you minus 2 of the order, or at most 3 of the order, because this is 1 over 200. Maybe you just reduce 2 order. So it's at least 8 plus 9, which is 17. So it's at least 14, 10 to the 14 hertz, 10 to the 14 hertz. Somehow like 500, yeah, 5 times 10 to 14 power, something like that. So 5 times 10 to 14 power hertz. So this is at least 5 order higher than the gigahertz. Gigahertz is 10 to the 9th power. 10 to the 9th power. Okay, so actually you can see here. So this is 5 times 10 to the 14 hertz. And this width, maybe I can make it F. This is F. This is delta F. So here is 7.49 gigahertz.